Okay, this is the video tutorial for lesson 11.2. This is Implicit Differentiation Part 1, and our objective is to differentiate an implicit equation. Oops, I'm actually on the wrong slide there, I apologize. So here was the warm-up for class, if you want to pause the video and then you can try and answer that question. So, here is the answer. I would say you can certainly multiply this out and then you can integrate this. Part B, find in terms of A the value of this. So we're going to integrate and then plug in those limits. The reason it says A is greater than 1 is because if it wasn't, then this limit would be smaller than this limit, which we don't really like for that to happen. So we substitute in the upper limit, which is A, substitute in the lower limit, which is 1, and then you have an equation that you can try and solve. Let's get back to this. So, deduce the value for 1 to infinity of 6x. This is one of those infinite integrals that you saw in AICE 1. And it's just state 4. So you don't get very much for this one. I guess this is where A equals, it's the same question, but A equals infinity. So 6 over infinity would just be 0, and 2 over, well, it's like 2 over infinity squared is just the same as 2 over infinity, which would also be 0. So yeah, 4, and that's why you only get 1 point for that question there. All right, we talked about the objectives in the previous one, so let's get straight on to implicit differentiation. So something that's implied rather than stated directly. Now, I always started off with this question here, and just ask students to quickly go ahead and write down the answer. And normally I don't have any problems with that. Normally they'll put dy by dx is 6x squared plus 3. And if you actually had this, then you actually just did some implicit differentiation without even realizing it. So the implicit part is the second variable. So this part here, 2x cubed, you knew the differential, that was 6x squared, differential of 3x is 3, and differential of 1 is 0. When you differentiate for y, you always put dy by dx. Now, we've only ever had questions that start with y equals, really, at this point. So this is where it starts to get a little bit more difficult. So, if the equation started with 2y, of course you could just divide both sides by 2. But the differential of 2y is, you use the same rules if you differentiate in 2x. So the answer would be 2. But the fact there's a y here, you would put dy by dx. If you had started with y squared, and that's kind of the important part for this unit, because we're looking at things like circles with x squared plus y squared, then you'd use the same rule as x squared, so you'd bring the power to the front and decrease the power by 1 with this letter, so it would be 2y. But to show that it's a y, you would also put dy by dx. And you could get questions more complicated than this as well. For example, you could have things like tan 3y, and the differential of that would be 3 secant squared 3y dy by dx, because it started with a y. So that's what implicit differentiation, the questions are going to look like. So here's the question that we're going to try and answer. We kind of saw the answer already, but that's fine. What is the equation of a normal to a circle with center 0, 0 and radius 10 at the point 6, negative 8? So we know an equation of a normal. We know that's going to do with tangents. We know it's the negative reciprocal. We know we need a slope, and we know we need a point, which they've actually given us here. So to find the slope, we're going to differentiate. Notice we don't have an equation right now, so this is why we had lesson 11.1 first. We've got to create the equation for this question. So, as I know the center is 0, 0, I can put x minus 0 squared plus y minus 0 squared equals 10 squared, which would just be x squared plus y squared is 100. Now, as I come to differentiate this, the differential of x squared is just 2x as we're used to. The differential for y squared, same rule, but as it involves a y, we also have to put dy by dx at the end of this. Differential of 100 is 0. Now, normally, unlike on that last question, normally it just says dy by dx equals. Notice on this one, it doesn't say dy by dx equals. So what we're going to do is, we're going to solve for dy by dx. So I can subtract 2x from both sides. I can divide both sides by 2y. And I could also simplify as well. So we have an equation for the slope on any point on the circle just by plugging in the values for x and y. So for this question, it would be 6 and negative 8. So I'd have negative 6 over negative 8, which should be 3/4. There we go. Now, that's the tangent though, but I don't want to know the tangent. I actually want to know the normal. So I would use the negative reciprocal, and I can also use the point slope formula for the point that was given. And you could multiply this out. Negative 4 over 3 times negative 6 is positive 8. so the 8's actually cancel from both sides. So you can either put y equals negative 4/3 x, or if you want to put it in standard form, 4x plus 3y equals 0. Let me draw a picture just so you can see exactly what we actually just worked out here. So here was the circle, there's the center 0, 0. We have the point 6, negative 8, and we have the tangent here. But the question said, what is the normal? Now, actually, if we realize this, what we're actually doing is we're just finding the equation of the line between 0, 0 and 6, negative 8. So you can actually do that way simpler than what we just actually worked out. This could actually, if I'd have showed you this picture, this is actually Unit 1 from AICE 1. So using geometry for this question, all I need is a slope and a point. So to find the slope, y2 minus y1 over x2 minus x1. There we go. We know it passes through 0, 0, and then we have our answer straight away. So sometimes it's quicker to actually use geometry rather than actually using implicit differentiation. However, not every question you can actually use this method for, so you do need implicit differentiation as well. But something worth thinking about. If you wanted to look at this picture, there is a link at the top there that you can type in and it will actually show you exactly that picture there. Okay, let's have a look at one of the questions from the textbook. So 1C, find the gradient of the tangent at 6, negative 8. So if I wanted to, I could try writing this in that center radius form. And then once I know what the center is, and I know a point on the outside, I can try and use that method you just saw a second ago. That's one option. I'm just going to go ahead and do it by implicit differentiation now. So differential of x squared, 2x. Differential of y squared is 2y. But as it's a y, I'm going to put dy by dx. Differential of negative 6x is negative 6. Differential of 8y is 8, but as it has a y, I have to put dy by dx. Differential of 0 is just 0. Now, very different from the last question. Not only does it not say dy by dx equals, it actually has two dy by dx's. So I'm still solving for dy by dx. So I'm moving my other terms to the other side here by doing the opposite. And then to get around the problem of having two of these, all I do is I take it out as a common factor. So I have dy by dx times by 2y, but I also have dy by dx times by 8. And then now, instead of multiplying this, I can divide both sides by that equation. And if it helps, you can simplify this as well. You can divide all these terms by 2. So you'd have negative x plus 3, or if you prefer, you'd have 3 minus x. And at that point, you can certainly go ahead and plug in the values that we know. We know that x is 6. We know that y is negative 8. And we can come out with the gradient of the tangent. So notice it doesn't always ask you to find the equation of the tangent. Sometimes it might just actually ask you what the slope is. But if necessary, you could continue here clearly, and you can actually do the point slope formula as well. And this was, if you wanted to do it the other way, I just wanted to go ahead and work through the question as well. So if you wanted to practice that, this is where we bring all the x terms together. We complete the square by doing half the coefficient. But 3 squared is 9 when I don't want anything, so I'm going to subtract 9. Half the coefficient of 8 is 4. 4 squared is 16, but I don't want anything, so I'm going to subtract 16. And then bring each of those numbers to the other side. And then from here, you can see that the center is 3. The radius is, the y value of the center is negative 4. And the radius is the square root of 25, which is 5. I don't strictly need that because all I'm looking for is the tangent, this one here. So if I find the slope of this line and then do the negative reciprocal, I could work that out. So notice I know 2 points that lie on the line. I could work out the slope of that, and then I could do the negative reciprocal. And actually in this question, using geometry was actually way more confusing, I would say, than actually not. So there are specific times when it's useful to use one method, and specific times when it's useful to use the other method as well. Question 6 is one of my least favorite questions. I keep saying every year I'm actually going to cut this question out. There are a few things on here that are useful to remind people about though. So when you're looking for x-intercepts, remember that means you set y equal to 0 and then you can solve. Or if you're solving for, when you're looking for y-intercepts, you would set x equal to 0 and solve. Domain and range is always important. If you want to show something is symmetrical about a particular axis, you're actually using those even and odd properties. So you would substitute in for x, you would plug in negative x, and check do you actually end up with the same thing. If you do, then that means it's symmetric about the y-axis. Or if you want to show something symmetric about the x-axis, you would replace y with negative y, and then you can check that as well. Probably the more useful parts is really probably part D, because we actually get to our implicit differentiation questions, and you can start to work out what the slope is for those. That does it for this video. Remember, this is just part 1, so when we get to part 2, we'll look at some more slightly complicated questions. But for this first lesson of implicit differentiation, that's it.